This exercise is the same as the previous one, only this time we'll be doing redistribution between EIGRP and OSPF. OSPF is actually configured on this side, and we'll check that. The only thing that's missing is to configure EIGRP and, of course, redistribution. Let's check the configuration on router 0, show running config. So we do have OSPF configured here. Okay, let's move on with EIGRP configuration. I'm gonna do configure terminal, router EIGRP, and I'll use the autonomous system number 1. No auto summary, network, we need to advertise 11.0.0.0 and 11.0.4.0. So let's do that. 11.0.0.0 wildcard mask, and then 11.0.4.0. Moving on to router 11. Enable configure terminal, router EIGRP 1. No auto summary, network 11.0.0.0.0.0.255. EIGRP informational messages are much faster than OSPF, so I'm gonna have to do the command again. 11.0.1.0 is what's missing. Moving on to router 12. Enable configure terminal, router EIGRP 1, no auto summary, and then advertising networks 11.0.1.0.0.0.255, and then 11.0.2.0.0.0.255. Moving on to router 13. Enable configure terminal, router EIGRP 1, EIGRP 1, no auto summary, advertising networks 11.0.2.0.0.0.255, and then 11.0.3.0. Router 14. Enable configure terminal, router EIGRP 1, no auto summary, network 11.0.3.0.0.0.255, and then 11.0.4.0. And that's that. Let's go to router 0 for redistribution. In order to redistribute EIGRP routes to OSPF, we're going to enter the OSPF configuration mode and say redistribute EIGRP 1 subnets. So this command is very similar to the RIP command. It's actually the same, minus this protocol change, but that's clear. Let's go to router EIGRP 1 to redistribute OSPF routes into EIGRP. Now, buckle up, this is a bit more complicated. The command is redistribute OSPF 1 and then metric, and then we start our journey. First value that we need to enter here is the lowest bandwidth link. So the bandwidth of the lowest bandwidth link in kilobits per second. And you can go from 1 to this big number here. I'm going to use 10,000. That's what you would usually use in a network like this. Next one is the delay in microsecond units. It's the delay for a packet to go through a network, but to know the exact value of this, you'd need to measure it. 10 would be a default value for a faster network, and 100 is the default value for a slower network. You can find this really deep in the Cisco documentation, but you're okay. For this smaller network, we don't have to be that precise, so I'm going to use 10. Next value is for reliability, and 255 is the most reliable. 0 is the lowest value, which would mean that your links go down all the time. And then I'm going to use 10 for, this is for load. It's also a 0 to 255 value, and it's for link saturation, kind of. 255 would mean that your links are constantly fully loaded, so we don't want to use that because that's not the case in this network. Probably 10 is a lot. We could easily use 0, but let's use something in between. And then 1500 is the maximum transmission unit value, the MTU, in bytes. So this is 1500 bytes. And 1500 bytes is the default value for Ethernet. So that's what we'll use here. And that's that. Actually, we could have used, I'm going to do it again, OSPF1 metric, and then use the question mark. This is what you should use every time you're doing this. You don't have to remember this by heart. Just know that for smaller networks, it doesn't really matter. You don't have to be too precise, especially because the metric is actually a way for a router to figure out which route is the best. And in this case, you don't really have many options here because you only have one way to go from this network to this network and the other way around. So yeah, I would use something in between, like values like this. That's actually it for redistribution. Let's check out the routing table. So for example, on this router, we should be able to see all the networks that exist in this topology of ours. Do show IP route. And yes, we can see all the networks. So the directly connected networks, the networks that we learned about through EIGRP, and then the networks that we learned externally, but then through EIGRP, since these networks were actually translated into EIGRP here. Let's do the ping just in case to see if everything's working properly. Yep, it is. All right, guys, see you in the next lesson.